Hello and welcome back. Let's continue to look at this example that we saw last time, where we have a plane flying directly over top of the house. If we move 100 feet away from the house, the top of the house and our eyes form a 15-degree angle up from the horizon. So this is called the angle of elevation. And if we look up at the plane, this is going to be an 89-degree angle as we're looking up above the horizon. So over here, I drew a more exact drawing. We have this triangle with a small triangle down here. The small triangle is going to be, okay, so we've got the top of the house and our eyes form a 15-degree angle with the ground. Notice that this is going to be a right angle triangle because this line is going to be going straight up and down. But if we look at this big triangle, we're going to be looking up at an 89-degree angle to try to see the plane up here. And we want to know how far above the house is the plane, as in what's the distance from the top of the house to the plane. So all we have to do now is try to figure out x. So we need an equation in here. We need to find an equation with an x in it. Well, x isn't even the whole length of this side of the triangle. So what I'm going to do is I'm going to add an extra letter down here. I'm going to call this z. And now x plus z is going to be the whole length of this side. So if I need to find x, I need to relate it to numbers that I know. And for instance, I know that I have a right angle triangle where this angle down here is 89 degrees. And this side length is 100. So what I can do is I can relate this side of the triangle to this side of the triangle using one of my trig identities. Well, if I'm using the 89 degrees, this is the opposite side, and this is the adjacent side. Opposite over adjacent is tangent. So let's write this down. The tangent of 89 degrees is going to be the opposite side divided by the adjacent side, which happens to be 100. I can then, maybe I'll write this a little bit nicer. I can multiply both sides by 100 to see that, that's meant to be an arrow, to see that 100 times the tangent of 89 is equal to x plus c. Cool. Well, I know I'm trying to figure out x. I don't know what z is, though. So it'd be nice if I could have a formula for z. Well, I've got this little itty-bitty triangle down here, and I can figure out z fairly easily because, again, I have a right angle triangle. I know one of the angles on the inside, 15. Z is the opposite side. 100 is the adjacent side. So I can play the same game. The tangent of 15 degrees is going to be z divided by 100. Again, opposite over adjacent. So what will happen here, if I solve for z, I get 100 times the tangent of 15 is equal to z. Well, now that I know what z is, I can plug that in there and solve for x. So plugging that in, my new equation is going to be 100 tangent 89 is equal to x plus z, which happens to be 100 times the tangent of 15. Okay, so then now I can solve for x by subtracting 110, 15 from both sides. So I've got 100 tangent 89 minus 100 tangent 15 is going to be equal to x. And again, tangent of 89, tangent of 15, these aren't the special angles that we were looking at before. So we will just come over to our scientific calculator. We'll have to take 100 times tangent of 89. And we're going to subtract 100 times the tangent of 15. And if we hit enter, we get 5,702. I'll just round to the nearest whole number, the nearest foot. So this is going to be 5,702. So 5,702, which is about 1 mile. Normally planes don't fly that low, but in this example that I made up, this is how just how the numbers worked out. And this will be in feet. We don't want to forget our units. So x here, the distance from the top of the house to the plane was 5,702. Cool. The last thing that I want to talk about are what are called bearings. This doesn't mean ball bearings. This is bearing as in the direction that a ship or a plane would be flying in. So to give a bearing, we have to say, okay, what direction are we going in? Are we going north or east or southwest? What direction are we going? But we might not always be going directly north or directly east. What happens if we're going somewhere in between? Well, there are 2 ways to describe the exact direction that you're moving in. The first one is just to give the angle going clockwise from north to the direction of our bearing. So this is a little bit different because we're going clockwise rather than counterclockwise for a lot of things. This is just something that we'll have to remember. So for instance, 20 degrees, we're going to form an angle going clockwise from north. So we'll start at north and then we'll start going clockwise until we get a 20-degree angle, which a 20-degree angle is about right there. So this angle here, which is 20 degrees, is going to help us point in the direction that we're moving in. So if our bearing is 20 degrees, that means we're going mostly north, but a little east at the same time. So we're going somewhere between north and east. Let's do some more examples. 90, 200, and 300. Let's draw a nice big one. North and south, and then east and west. So find the bearings. 90 degrees. Well, 90 degrees is going to be a right angle. So if we go 90 degrees clockwise, we are going to hit directly east. So east. This is going to be the bearing that is 90 degrees. So again, if we start at north and go 90 degrees clockwise, we hit east. So if you are listening to say planes or ships talk to one another and they say we are going, in this direction at this many miles per hour with a bearing of 90 degrees, well, 90 degrees will mean due east. So what about 200? Well, this one is a little bit harder. So we should think carefully about this. So if we go 200 degrees from north, we know that, for instance, if we go 180 degrees, we'd be going in exactly the opposite direction. That's 1/2 of a rotation. And 200 is going to be a little bit more than 180. 200 will actually be 20 more than 180. So if we go 200 degrees, we're going to be pointing right here. So again, how do I know this? Well, this angle right here is going to be 20 degrees. So if I go the entire angle from north all the way down to here, this is going to be 20 degrees plus 180. So that's going to be 200. So this is going to be a bearing of 200. And then a bearing of 300 as well. So again, east is 90, south would be 180, west 3/4 of the way around, 3/4 of 360 will be 270. So we can see that we're even past 270. And how far past 270 are we? That would be 30 degrees. So we are going to be 30 degrees past this. So it'll be something like that, where this angle is going to be 30, so that the entire angle from north all the way around to there is going to be 300. So it takes 270 to get to here and an extra 30 to get to our bearing, which is going to be 300. Cool. So let's find some more bearings. Let's find the bearing for due south and northeast, halfway between north and east. Well, we've already said what the bearing for due south is. It's going to be 180. Again, because we've gone halfway around this, the circle, halfway around our compass to get to south, and 1/2 of a rotation is going to be 180. Northeast, this will be slightly different. So halfway between north and east would be about right here. And we know that if we want to go halfway between two angles, we're cutting the big angle in half. So to get from north to east is a 90-degree angle. So we're going to cut that in half, so that both of these are in fact 45-degree angles, which is half of 90. So this bearing here is going to be 45 degrees. So northeast is a bearing of 45 degrees. This works well. This is one method for giving a bearing. It's just, again, you see how many degrees past north have you gone in a clockwise direction. Another way to do this is using method 2, and the description I have here isn't, I don't think is the easiest to read. I think it's best with an example. So we have north, east, south, and west. And the idea is that the first direction is either going to be north or south. We always put north or south first. And then we're going to bend either in the direction of west or east by this amount. So, first step, we identify south. Okay. Next, we want to go 60 degrees away from south in the direction of east. Well, east is over here, so we're going to be in between south and east, and we're going to form a 60-degree angle with south. So this angle right here is 60 degrees. Note that we're on the east side, not on the west side, so this bearing is going to be south 60 east. Okay, so all we're doing is we identify what direction are we going to be pointing in first, either north or south, and then we're going to bend this far in the last direction, either west or east. So let's do a couple of these. Let's rewrite the following bearings using method 1. So north 10 west. So we're going to be pointing north, and then we're going to bend in the west direction, and we're going to bend 10 degrees. Okay, so the question is, what is the bearing using method 1? Well, if we start from due north and go all the way around, I need to find this big angle here. Well, this isn't too bad. A full circle would be 360, but we stopped 10 degrees short of that. So we didn't go all the way around, we stopped 10 degrees short, so this is going to be 350. So this bearing is 350 degrees. Nice. Next, south 20 west. So again, we have south. Over here we have west. And we're going to form an angle of 20 degrees with south. And now I need to find the angle from north to this bearing, which from north to south is going to be 180, and we've gone 20 past that, so 180 plus 20 is going to be 200. So this is a bearing that we already saw before. Let's do a couple more. So I want to rewrite the following bearings using method 2. So again, these are in method 1. So 30 degrees means that we start at north and we go 30 degrees over. Well, this is pretty simple. We started at north and we went 30 degrees over toward east. So 30 degrees is going to be north, 30, east. Easy. The last one is maybe a little bit harder. 135 is going to be down here. This is going to be 135. And if we do the math, I'm running out of time, but if we do the math, this angle is going to be 45 degrees, which is going to be south, but also in the east direction. So this is going to be south, 45, east.